Use your unit circle. As you use your unit circle, I've been harping on you guys to consistently look at placement of angles as they're being spun within the specific quadrant, and looking to see if you can figure out where its reference angle is located. We've done a ton of talking about reference angles in relation. Take the earphones off. I don't want it. It's just annoying me lately. As you go through, as things mirror themselves throughout the quadrants, as you look at the first ordered pair, the only one you had to figure out, 30 degrees. It's the smallest of them. That's the only thing you really need to remember, because then you know how to find a cosine, how to find a sine by drawing the right triangle. As you draw the right triangle, you know that your opposite is a 1, the adjacent is a √3, your radius is a 2. You knew that I've been telling you all along that cosine comes first. Cosine is your x value, √3/2. Your sine comes second because it's second in the alphabet. It's your y value, 1/2. These ordered pairs just do you mind? Thank you. These ordered pairs just rotate themselves through for each one of the angles that has 30 degrees as a reference. What happens is that reference angle allows you to then change their signs, S-I-G-N, as they're going around the circle. First quadrant, you have positive, positive. Second quadrant, you have negative, positive. Third quadrant, you have negative, and then positive, positive. Okay? So now what I want you to think about is that we have cosine and sine. If I throw cosine and sine in the second quadrant, think about how that looks with the reference angle. Reference angle comes up pi over 6. Which value is negative, the x or the y? Yes. So as you draw your triangle, you realize that's the negative √3, and there's your 1. What happens to tangent then? Is tangent going to be positive or negative in the second quadrant? Are you sure?
Yeah.
It's negative.
Negative. So.
Tangent winds up being negative because tangent's opposite over adjacent. Your opposite is positive, your adjacent's negative. What's a positive divided by a negative? Negative. Yes, ma'am.
Why isn't it a 30 degree long?
It is. It's 5 or 6.
Oh, it's 30%.
Okay. As I move them down to this third quadrant, they would both be negative. Yes, sir?
Can you explain the tangent thing again? Is it just the location?
Yeah. Yeah, we're getting into how we can locate it via x's and y's here in 1 second. Tangent, remember, is opposite over adjacent. My opposite is a positive value. My adjacent is negative. What's a positive divided by negative? Negative. Here, if I drop to the third quadrant, I have an opposite of -1, adjacent of negative √3. What's a negative divided by a negative? So what's tangent in the third quadrant? Positive. Yes. Makes that one negative because
Multiply or divide instead of sine.
Yep.
How do you know when you sign those?
Can I ask you? I'll tell you. Okay. Yes, sir.
I had another question. It wasn't really related to that. Though. You have 2 as the hypotenuse of the 30, 60, 90 over there, because that's what it is. But if you drew in the 45 one, wouldn't it be √2 there, not 2?
Yes, and there's a reason why this happens.
But isn't that just the radius? So wouldn't it be the same?
The reason that it happens is because when we talk about the unit circle in and of itself, the unit circle is some scalar. Right. Because and I think somebody asked something about that earlier yesterday. What happens if your radius is 8? And if you're at a radius of 8 and you're at a 45 degree angle and this is 8, I can still figure out my 2 other side lengths because there still had that ratio of the √2s in there. So if this was 8 something times the √2 to get me the radius of 8, that scalar, that unit doesn't change. Does that make sense? And plus, when you divide things out, they all simplify out anyway. So it's kind of cool how it all you really have to know are your 2 specials. Okay? So what I want to get into today is obviously the signs, SIGN, as they rotate themselves through, but I also want to be able to pick out a specific point within the two-dimensional plane and figure out the trig functions via that, by using Pythagorean theorem. Okay? Bella?
What's the difference between SID and SI? Because you keep like,
All right, to change the SIG, did we just?
Wow.
Wait, hold up. All right, to change the sign, it's not complicated, right? It's just, you just move it and then you change the sign or you do the next. Okay, just make sure.
So when you take a point in space, you take a two-dimensional plane,
Is it 13 seconds?
we have some origin, okay? Yes, sir?
Are we going to be expected to like essentially memorize this whole thing, whether it is just by learning that very 30 degree? Sort of remember the whole thing.
You need to know it.
Okay.
What I'm getting at is you really only need to know minimal amount of it because it's all built off the same things.
Right.
Once you master the idea of a reference angle and where the SIGNs change, you're going to be fine. So you take any ordered pair. If I take any ordered pair and I pick a point in space, for example, let's say it's -3 and 4. If I want to place -3 and 4 in the coordinate system, what quadrant will it lie in? 2. Good. So I go in here, I have -3 and 4. That point is about there. So this gives me a terminal side of theta as it comes around. Remember how we did that? It comes back out this way. So there's some angle that's larger than 90 degrees that created that value. But yet, I can figure out the rest of this. I can do my 6 trig functions off of this because I can create a right triangle. I place it with a theta. Your theta gets placed as a reference angle. How far is it up off the axis? You put the -3 in the here, and your 4 there because that's your x and your y. What am I missing? My hypotenuse. What's my hypotenuse?
This is
5.
5.
It's a 3, 4, 5. It's a triple. So now, what happens is if you place a theta in here as your reference, and you know your adjacents and your hypotenuse and all that stuff, you can relate sine, or I'll say cosine, sine, and tangent in relation to x, y, and r for our radius. Now, that's kind of what you were getting at about why does the radius change, but yet it still works. It's because of the scalars. Not every one of our angles is going to land us within our unit circle. It's not always going to get to 30, 60s, and 45s. Sometimes you're just going to have to figure out the fractions, okay? Because we're not using calculators for this stuff. We're just figuring out fractions. What angle has, that kind of thing. So cosine, if I'm looking at this in terms of cosine, we know cosine is adjacent over hypotenuse, but in terms of x and y, what would that be? What's your adjacent? Is it an x value or a y value? X. So cosine is x over r. What sine?
Y.
Y over r. What's tangent?
X over Y.
Try again.
Y over X.
Reciprocal properties. Reciprocal properties of trig functions are just flip the fractions. The reciprocal of cosine is secant. If cosine is x over r, what's secant? R over x. Reciprocal of sine? Cosecant. R over y. Reciprocal of tangent? So what this allows you to do is take the trig values of any point in space in relation to its reference angle theta by using Pythagorean theorem. Yes, sir?
What is it? Is stenos?
Theta.
Theta. Is theta just like,
Theta is the reference angle for where the terminal size lies in.
okay, so.
We've been talking a lot about reference angles. Reference angles are always going to be the angle after the terminal side, where however closest it is to get to the x-axis. You're always bounced to the x-axis. First quadrant, they are their own reference angle because it comes up to the terminal side. Second quadrant, you got to come down to it. Third quadrant, you got to go back up. Fourth quadrant, you're off and too high.
Okay, so then
Theta.
theta. So theta is just a variable, you could say?
Yeah.
Okay.
Yes, sir.
So in a problem like this, what would they ask for?
What are the 6 trig functions that give an ordered pair?
And you just have to.
Yeah.
So how did you find 5? Is it just because you know it's a group of 5?
Yeah.
Okay, cool.
Let me do an example.
Oh, this is out of order. I just forgot all. No, I forgot.
Negative 12, negative 15. Let's write out the 6 trig functions at negative 12, negative 15.
You got it.
I don't know. First thing you got to figure out is what quadrant you go.
Oh, I mean, three. It's three. It's like,
Oh, yeah.
So you have a point in space in the third quadrant, terminal side third quadrant. Theta is bounced between that to the x-axis, which gives you an opposite value at theta of what?
Negative 15x.
So again, if you're putting a value, your x is left and right, your y is up and down. So what is my opposite to theta? What is my x to theta? How do you solve for r? Pythagorean theorem. Yes, sir.
so this is placement, not points. This is placement, not distance, right? So it can be negative.
Yeah.
Okay.
So use Pythagorean theorem. You get 144 plus 225 is what? 369. Square root of 369 is what?
19.219.
What is this decimal crap you're saying?
It's just the square roots.
Okay. So we need to know how to simplify radicals.
3 root 41.
Guys, you have to know how to simplify radicals. There are no such thing as decimals. You have to work with radicals and simplified radical form. Nope, not anymore.
One thing.
You're not getting a calculator. So go to your y equals. In your y equals table. If you forget how to simplify radicals, you just type 369 divided by x squared. Bless you. Oops, it depends on the problem I give you. Some of these are easier than others. Whoop, that's awful.
41.
Anyway, so it's 3 root 41. Which means you go through and you write out your 6 trig functions. Cosine, sine, tangent. So you know that cosine is going to be your adjacent over hypotenuse. Yes, ma'am?
How do you know that you're finding that side? How do you know it's not like the other side?
Because you never know, you won't know you're given a point in space. Your point in space is an x and a y coordinate. It's not your radius.
Like, do you know, I don't know, like, which side, it's not the other side? Like,
Oh, theta's always put to the origin. Theta always backs to the origin.
it's closest to the
Theta is always placed next to the origin. Theta will always be next to the origin as the reference angle, as how far it came up from there. Theta is all. That's the rule for theta. Okay.
Wait, theta with I thought it was.
So you get x over r, so it's negative 12 over 3 root 41. Now, obviously you're going to have to simplify it and then rationalize. So you're going to get negative 4 over root 41. When you go to rationalize that, you have to multiply top and bottom by root 41. Vaguely remember that?
Yeah.
You probably did a lot of this with like root 3s and root 2s and stuff. But before I do that, I'm going to take a second and do the reciprocal property for cosine, secant. The reason why I'm going to do that is because I know what it is. It's root 41 over negative 4. So I don't have to worry about the rationalization part. Does that make sense? You can, it's just not a big deal. So now when you rationalize it, you're going to get negative 4 root 41 over 41. So if I flip that, and then I have to re-rationalize, that's all I'm getting at. It's just sometimes a lot quicker to do it before you rationalize stuff. That's all. Okay. And then you just go through the rest. Yes, ma'am. That's how it simplifies radicals in the calculator. Ah.
We just moving on.
Quadrantals. Quadrantal angles. Your quadrantal angles. Quadrantal angles may be the most important angles on the unit circle.
No way.
Anytime you guys want to stop the comebacks, it'd really be great. Quadrantal angles are the ones that lie on the axis. Quadrantal angles lie on the axis. They are at 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. The unit circle has a unit of measure. We have given it 1, which means you can then find the ordered pairs for each of those 4 points. If this was moved out 1, what's the ordered pair there? 1, 0. What's it at pi over 2?
0, 1.
0, 1. Negative 1, 0. And 0, negative 1. So that tells you that at 0, cosine is what? 1. At pi over 2, cosine is, at pi, cosine is
Negative 1.
at 3 pi over 2, back to 0. Then when we get back to 2 pi, it goes back to 1. So it completes a cycle. Same thing with sine. Sine starts at 0, 1, back to 0, negative 1, and 0. This allows you to take graphs. Where did sine start again? 0. The next time we saw it, it was at pi over 2. Or was it there? The next time we see it is back at, and it's where? And then it ends up again at?
0.
At 2 pi. So sine starts at 0, cycles itself.
It's like an unraveled circle.
It's
Yeah,
what do you
it's
call
like
it?
unraveled.
No.
Yeah.
It's
Oh, that's
it's
not
not a hyperbola, it's what do you call it?
Sinusoidal graph?
No,
It's on the graph.
It was chapter 8 or whatever.
The number of exponents equals the number of terms, whatever.
Oh,
Just like
something.
something.
Where? Yes, sir.
So is it kind of like when you like take a piece of wire or whatever and you wrap it into a circle and then you let it go and it like
No.
if you look at it from the side.
Cosine. Where does cosine start?
1.
Cosine starts at 1, goes to
Zero.
-1,
Negative one.
0, and 1. What does tangent do?
Nothing.
What's the tangent at 0? Tangent was y over x. What's 0 over 1? 0. So tangent starts at 0. Now, unfortunately, at pi over 2, you get 1 divided by 0. Can't do that. So what happens? It's undefined. You get an asymptote. Somewhere along the lines between 0 and pi over 2, tangent has the same coordinates, opposite and adjacent. At pi over 4, you get root 2 over 2, root 2 over 2. Yeah, you know the answer. You're going to find the reciprocal properties as well. Oh, you'll graph arc sine, shifted. Okay. Tangent of 45 degrees is 1. So at pi over 4, it's 1. At negative pi over 4, it's -1. Tangent's the fun one. It has asymptotes. So eventually, we're going to take our circle and switch it into a graph. And yes, there will be AH's and K's. There will be BX's and C's, a couple of different ways of graphing these. There we're going to, I know, if you guys saw anybody in pre-calc in the past couple of weeks or whatnot, we were graphing some of the inverse straight functions. This year we are, in honors, we are going to introduce a couple of those. Maybe not so much with shifts, but just some standardized ones. It's fairly simple. But yeah, this is where all of this heads to, but it's the idea of understanding why are quadrantals important. Quadrantals are important because at pi over 2, if I take 6 trig functions at pi over 2 as an ordered pair of 0 and 1, cosine is what over what? Cosine? Adjacent hypotenuse. So it's x over r. So this is 0 over 1, which is 0. Sine is y over r, which is 1 over 0, which is undefined. Oop, sorry, did I read? No, this is 1 over 1. I'm sorry, I wrote that backwards. 1 over 1. I got ahead of myself. Sine at 90 degrees is 1 over 1. Your opposite over your hypotenuse. Excuse me. Tangent is your y over x, which is your 1 over 0, which is undefined. Think about reciprocals. What's the reciprocal of 0 over 1? You're right. Yeah. The reciprocal properties would be r over x, which is 1 over 0, which is undefined. Same idea is when you guys had slopes. The reciprocal, what is opposite reciprocal to parallel? Perpendicular. What is the reciprocal slope to a 0 slope? Undefined slope. It's the same basic idea. What's the reciprocal of 1? 1. The reciprocal of undefined.
0.
Quadrantals allow you to do that. Yes, ma'am.
How did you find the radius?
Radius of the unit circle is 1.
All the time?
Yep, that's why we call it the unit.
Oh,
Because if the ordered pair here is 1 and 0, that means the radius here is 1. And the radius here still is 1 as it goes to 0, 1. Okay. The radius takes the place of whatever axis it's on. If it's on the x-axis, it's 1. If it's on the y-axis, it's 1. Okay? Because your points are there at 0, 1, 1, 0, that kind of stuff. Even if there was a scalar involved, it would still work the same way. If it was at 4, 0, it means your a's is 4. What's 4 divided by 4? 1. That's why we just don't worry about the scale factors of these things. Okay, so you can think it all through. So when you're using quadrantals, it's a matter of picking the ordered pair and just writing out x, y's, and r's. What does it all stand for? Quadrantals allow you to be able to graph this stuff. Don't worry, we're not doing this for a few weeks, but this is where we head. Okay, this is where we head with this stuff. Okay.
Wait, can you leave that up just a minute?
What's that?
Can you leave that up?
Oh, yeah, sure, no problem, no problem. Now, yes, sir.
For the graph, is it, for cosine and sine, is it just start at 0 or is it negative?
There are negatives, it depends on what your A value is, and we get to that. I'm just showing the generic idea of why do you need to know about the quadratics, because they're the points of inflection as things are changing. We good? Sweet. All right, so now the next cool thing, well, I says the math teacher. Just real quick reference angle review. Reference angle is always distance off of the x-axis. You're always distance off the x-axis. It's always a positive distance where theta is placed at the origin. Okay. Always, always, always. So your theta would be here. So if it dropped to the third quadrant, that means you'd have an angle, say, 200 degrees. Which means your reference angle would be how many degrees past 180? 1. Little quick stuff like that. Yes, sir.
It's only the distance off the x-axis that's positive.
Unless
Even if I have a negative angle, it's just spinning the other direction, it still has a positive reference angle. Yes, sir.
Yeah, that was my question.
Yeah, your reference angles will always be positive because reference angles will now allow us to figure out where we lie in a quadrant to know which triangle that we're going to use.
what if that little thing would be like? Oh, is that theta? Okay.
I'm just showing that theta is placed there. Yes, sir.
So, the reference angle will always be less than 90?
Yeah.
Okay.
Yep. Good point on that one. And remember, anything in quadrant 1 is a reference angle. Quadrantals aren't reference angles. Quadrantals are quadrantal angles. They're fancier. Okay. Which means I can take something like, get to the right one. Got it out of sequence. Find the tangent at negative 210 via reference angles. Yes, ma'am.
By definition, what would it
An angle that lies on one of the axes. One of them. That's all. Yes, sir.
Would you ever have to find the reference angle?
No, because it's different. Quadrant was a quadrant. Okay. So here's what happens. What we're going to do is we're going to take tangent negative 210, and we're going to figure out what that is without using the calculator. First thing you have to do is get the reference angle to figure out what. JC, don't be so worried.
I'm very worried.
Don't worry.
So,
All right, JC, help me out with this one. What direction am I going to go?
this way.
Then you're halfway done. Okay? Negative 210 spins you to what quadrant?
Third.
Sends you second quadrant, gives you a reference angle of how far off?
30 degrees.
Perfect. So you know that you have a reference angle of 30 degrees, which means which of the two triangles are going to use, 30-60 or a 45? 30-60. So I take a 30-60-90 triangle. Oops, sorry. 1, √3, and 2. That's the ratio of the sides. Do you agree? Yep. What's the tangent at 30 degrees? Tangent of 30 degrees is 1 over √3, which is √3 over 3. So, you've got that done. Is tangent positive or negative in the second quadrant? It's negative. So your answer is negative √3 over 3. You spin it to win it. You spin it to figure out what quadrant you're in, get the reference angle, draw a triangle. Okay.
Let's say you get the 1 over root 3, but how do you go from 1 over root 3 to root 3 over 3?
Rationalize. Multiply top and bottom by the radical.
Oh, okay. Okay. Thank you.
No problem. Cosecant 11 pi over 4. First of all, cosecant is the inverse of which trig function? Sine.
Yeah, that's what I was wondering.
I have no idea. Once again, 11 pi over 4. 4 goes in 11 how many times? 2. So this is 2 3/4 pi. So I spin around. There's 2 pi. Now 3/4 pi. What quadrant does that get me to? 2 again. What's the reference angle? Perfect. I have a reference angle of pi over 4, which is a 45-degree angle. So I draw by 45/90. 1 root 2. Cosecant is the inverse of sine. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite, so you get root 2 over 1. Is sine positive or negative in the second quadrant?
Negative.
Positive. Y values are sine.
Wait, so how do you know which is which?
Because it's cosecant instead of just.
Order. Remember? Cosine, sine, cosine, sine, cosine, sine,
Okay, so
cosine,
your x value?
sine. Yeah.
Sine is your
Yeah.
y?
So what am I getting at this whole time?
So what's tangent?
Tangent is y over x. So where, that's why you have, in the third quadrant, when you have negative divided by negative, you get positive. Ratio of special right triangles, 45, 45, 90 is x root 2, so it's 1 root 2.
Tangent's opposite of just.
Because pi over 4. Pi over 4 is 45 degrees. Let's do another one.
I didn't hear one of
No, it's positive.
Sine 7 pi over 4. Sine of 7 pi over 4 is 1 3/4 pi. How far off of 45? So it's pi over 4 away. So you have a reference angle of pi over 4, which means, like you guys were saying, it's a 45, 45, 90, 1 root 2. Sine is what over what? Opposite over hypotenuse. Very good. So this would be 1 over root 2. So the sine here is going to equal root 2 over 2. Is the sine value positive or negative in the fourth quadrant?
Negative.
Go to the next problem.
What if it's not as easy as getting 30, 60, 90, or 45?
Can't do it.
Really?
You have to use a calculator.
Oh, so I was like,
You won't.
you got it.
Can you do it with the calculator now?
With this? Yeah.
But it won't.
Put your calculator in radians and it'll give you some decimal answer. Multiply it by 2 and square it. You're going to get 2. Wait, the button says mode. Yes, sir.
That's the final answer.
Yes, sir. Negative root 2 over 2.
I thought it was both, because it was both negative and it was not 2.
What happens here is you've got, this is positive and then negative, so the sign value is negative.
I got the quantity mixed up.
Okay. See, you got the crazy worry face going for a second there. All right.
Set the clock.
Tangent 240, or excuse me, cosine 240. Yes, sir.
If it's not in the special triangles, are we going to still be expected to do the exact answers? If so, how?
You can't.
Okay.
And I think I'm going to leave that for pre-calc for you guys. You can do half angles, like half of 30 is 15. You can do half of 90, obviously it's the 45, half 45 is 22.5. There are specific formulas for that, but it's something we don't deal with in altitude. We normally don't. I think this year I'm just going to do the inverse graphing, but not worry about half angle stuff this year. Yes, ma'am.
2 things. One, our test period not getting tested, right? So for all of these, will be special training.
You can't do it without.
But, okay. And are we getting reasons?
Oh no. Oh no. You don't need it. Draw a triangle. What quadrant is X and Y positive? That's it.
1.
X and Y are positive here. Where is X negative, Y positive? Where's positive, negative?
4.
And then negative, negative. I mean, as long as you know that, you know all your signs, SIGN, to make it work. Okay? 240. Where does it go? Third quadrant. With a 60-degree reference angle. 60 degrees, pi over 3. Oops, 60. Cosine of 60 degrees, 1 over 2, so it's 1/2. Is cosine positive or negative in the third quadrant?
Negative.
Negative. So your answer is?
Negative. 1/2.
You can check that one.
I'll check it. I'll check it already.
I just, oh.
Nope. What happens is the negative value is the x value is negative.
Yeah, but it's a radius
Why?
was negative, and then
It won't work. Radius is always positive because of Pythagorean theorem. Your x squared, y squared gives you positive r value. Yes, ma'am?
Is theta always the reference?
Yeah. Sometimes they'll put theta. They'll ask you where theta is in terms of placing it, but normally it's technically theta prime.
But is it Pythagorean theorem going to be plus or minus?
No, you're taking square root and you have negative distance.
No.
Wow.
But negative square root.
What you're finding is you're finding the distance from this point to this point.
Pythagorean theorem, just take the square root or something. Yeah. The answer would be plus or minus.
But you're finding the distance here from the origin to that place. You're finding
so x
the
and y is usually a distance since it's negative.
it's a place in space.
Okay.
Okay. All right. Let's do cotangent negative 3 pi over 4.
Mr. Murphy, I need you to go back and take a step.
It doesn't.
What's that?
With the one we just did, where it was cosine of 240, I'm confused again why it's negative and not positive. Because this time it is in the quadrant where it would cancel it.
Because you're using the hypotenuse, which is positive.
Hypotenuse is always positive.
It's always positive.
Yeah, that's what we were just getting at. Because if you're over here in the third quadrant, and if I draw this correct, if I draw it nicer, you have a 60-degree angle here. Your adjacent is the -1. Your opposite is the -√3. -1 squared plus -√3 squared is 4. Square root of 4 is 2. So your radius is always going to be positive. Okay, your radius is always going to be positive. That's why it doesn't work. That's why it's doing that on you. Okay. Your r value is always going to be the square root of your x squared plus y squared. Okay. Back to what I just had there. Might be the last one I get in here. Cotangent negative 3 pi over 4. Cotangent negative 3 pi over 4. Spin it. Negative 3 pi over 4 just tells me I go the other direction.
Yep.
Drop into what quadrant then? Third quadrant. Very good. Third quadrant. 45-degree angle, reference angle. What is the tangent of 45 degrees?
-1.
So here would be -1 over -1. So your answer is 1. All right, so we skipped a bunch of steps here. Anyway, the reference angle here is pi over 4, which is a 45-degree angle. So at a 45, 45, 90, your side lengths are 1, 1, and √2. Cotangent is the inverse of tangent. Well, cotangent is opposite over adjacent, and adjacent over opposite, in this case, are both the same, 1. In the third quadrant, they're both negative. Negative x, negative y. So negative divided by negative is? And that's how this works. Oh, trigonometry, you're so cool.
Can you do like cosine on the calculator?
You have to use reciprocal properties. What we have in the calculator are arc tangent, tangent negative 1, that's what that stands for. We don't really use, because you just use reciprocal properties, it's easier.
Let's watch the trailer for that.
Yeah, right. So let's see, let's do, this is 13.3, page 788. Oop, 30 to 36, and then 45 through 60. Oh. Okay. It's just a lot of spinning.
You're killing me, Smalls.
You'll get over it. Okay, it's a lot of spinning. No.
What?
Really good. You're taking
Awesome.
kids. It's a good family thing.
Yes!